Hey, this is Corey Glenn, and this is a little bit of an unusual video, but just had a lab contact me, and they have a rush case that they've got to get this particular tube fabricated for a customer's case, and it's too late to order it to get the tube in time. So fortunately, they do have the ability to mill this, and so I'll just show you in Meshmixer how I'm going to reverse engineer this. And so this will just be useful if you don't know a lot about Meshmixer and you want to learn more about trying to create parts and that kind of thing. So to start the case, I've got to import some kind of object, so I just told it to import a sphere, and then I'm almost going to immediately get rid of that. But if I go up here to Meshmix, I can use a cylinder, and so let's pull a cylinder into the case, and what I want to do is go ahead and make this cylinder be the correct outer diameter. So again, if we go back to the outer dimensions, this needs to be 6.09 millimeters on the outer dimensions, and so I'm going to change this. I've got uniform scaling on, so 6.09, and that's going to make it 6.09 in all dimensions. Now we can change the length of that, and so I could do that by stretching it, and you see which parameter that affects. Let's go back now and look at what is the total length of that tube. So the total height of the tube is 5 millimeters. So back to Meshmixer, we're going to change this number to 5, but I've got to turn off uniform scaling to do that. Otherwise, it's going to change all the parameters to 5. So now we've got a tube that has 5 millimeters in height. Then I'm going to go ahead and accept this, and now I'll just delete that sphere. Okay, so this is the starting point. This is going to be our outer dimension of the tube. Now it's also got a 1 millimeter lip, so let's create that lip. So I'm going to go ahead and go to Edit, Duplicate. So now I've got 2 of these, but this one I need to make a little bit larger in diameter. So if I push T for transform, it brings this back up, and let's make this 7 millimeters. We can turn on uniform scaling just so that it makes everything be 7 millimeters, but I don't need that much height. What I need is just 1 millimeter of height. So let's do that. Oops, see, even I did a mistake here. I don't want to uniform scale that. I just want to make it 1 millimeter of lip height, because again, this tube has a 1 millimeter lip. Okay, and it doesn't add a millimeter of that lip to the height. The total height is 5 millimeters, so there's basically a millimeter of lip and then 4 millimeters of tube. So back to Meshmixer, we've created a lip now. I'll accept that, and now I'm going to just take my slider, slide this up to where it corresponds to the very top of this. Now this is not down to the micron accurate, but it's incredibly close, as you can see here. All right. And I could even play with that just a hair and try to get those where they coincide perfectly right there. Okay, so you can see it bleeding through the other just a little bit. I'm going to accept that. And now what I want to do is create the inner diameter. And so let's go back to our page. This tube inner diameter is 5.13. Okay, so I'm going to once again take this original tube and duplicate it. Okay, so duplicate, and you might ask, why not just go up here and grab another cylinder? Well, if I just grab another cylinder and drop it in there, I don't know that it's going to be perfectly concentric. By duplicating these tubes, I do know that it's going to be perfectly concentric because it's right within that. And so now I'll just take this tube, let's turn that off, T for transform, and let's turn on uniform scaling, and I'm going to make this be the inner diameter, so 5.13. And with that done, I'll accept it, but then I'm going to push T for transform again, and this time stretch it. Okay, so now I can subtract that from these other 2. So we've got everything we need to make this tube now, and just a quick tip I've picked up over using this over quite a while is that you want to go ahead and make these solid. So the first 2, I'm going to go up to the top and combine them, and then I'm also going to make it solid. And without getting into too much detail, the reason you do that is because when you make it solid, it's just going to have a lot easier time doing the Boolean difference. So I'll update this. I want it to be high accuracy, and I'll accept that. And as you see, it will turn the visibility of the original off, and it creates this new surface. All right. And then I'll hide that for a moment. I also want to make this solid. So edit, make solid, accurate. Let's go up to a little higher accuracy and update it. And there we go. So now these are our final two. And so if I click on the original, okay, this is the object I want to subtract from. This is the object I want to subtract. So I'm going to select the object I want to subtract from first, and then go to your objects browser, control, select it, and then Boolean difference. And we'll go ahead and accept that. And here we have the exact replica of that guide tube that they are needing. So I'm going to send them this STL, and they should be able to machine this. So again, not something you'll necessarily be doing day to day, but hopefully it just shows you a little bit about doing the Boolean functions, combining things, how to reverse engineer stuff. Just hope that that's useful.